Hello to some Year 6 students, welcome to Science, Mr. Robertson, and I'm back. And we've been doing about day and night and the year and things. And I've told you, we have our sun in the middle, and our Earth, and all the other planets going around the sun. That is true. That is not what we used to believe. We've got to focus on that in today's lesson. Because of course, what do we see every day? What we see is an Earth that looks a bit like this. And we see the sun go up, sunrise always in the east, every day, always the east. Going up and coming down once again in the west. Every single day, we see the sun go up and we see it go down. Now, there's no reason for us to think, hey, it's not the sun moving, but we're moving. It looks like the sun is moving. And if I stand still, do I feel that I'm moving? No, I don't. So it was really easy for those scientists a long time ago to get this wrong. And they did get it wrong. They used to have a model that had the Earth at the middle of everything. It is what we call a geocentric model. Geo meaning Earth, centric meaning center. Earth-centered model. Because the Earth is still. The Earth is not moving, and everything else is moving around the Earth. So that must be true. And of course, the first thing, the closest thing would be the first orbit, which was Moon. Then the next closest thing going inwards would be Venus, and then Mercury. And then, of course, the Sun. Because Venus can sometimes be between Earth and Mars, so Venus must be here. Mercury must be here, because Venus could be closer to Mercury, but Mercury could be closer than the Sun. And then from there it went out Mars, Jupiter, Saturn. Didn't know any planets beyond Saturn at the time. This was the model that scientists used to believe. We had this idea that the Earth was at the centre. And of course you'd have on the outside, you'd have all the stars. And the stars also move in the night sky. You can see them change shape. So they must have been flying around super fast in this system. You can make it work. It's very hard. It's almost impossible maths, but you can make it work. But it's not what really happens. What really happened is actually a lot more simple. And it is the idea we have today. And the idea we have today is not the geocentric, but the heliocentric model. Helio meaning sun. So we have our system that we know today, our sun in the middle, and then my very effective memory just stores up 9 planets. But it's not 9 because we have no Pluto. Pluto as a planet we will look at later on. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune are the 8 planets we have in the solar system. And of course, in this model here, it was the Earth that was spinning. Now, for every day and night it was spinning, and the Earth was going round the sun. That meant all of these stars could now be still on the outside. Now, we know the stars are not still. They are also moving. But compared to where Earth is, it's close enough to being still. They're just so far away. How we did this was actually really, really clever. So, there was a person called Copernicus, a famous Polish scientist, and he looked at the movement of Mars. Now, the numbers I'll give now are not perfect, but they'll explain what happened. So, it takes Earth 1 year to go around the Sun. So it goes whee, like this. Mars has a slightly bigger orbit, like so. Mars is 2 years to go around the orbit. So if Earth and Mars are both here, then Earth is going to go this in 6 months, and in the same time, Mars will go only this far around, because it takes 2 years. So det tar 2 gånger mer tid to go around. So it's only gone halfway. Now, if I'm on Earth here, and I'm looking at Mars, and I see all the stars in the background here, it looks like it's going backwards. As I go over here, remember, light was in one straight direction. As I go further and further away, it looks like Mars is getting slower and slower. It can't keep up. Earth is going faster and faster and faster. But that's not exactly how it works. You actually get to a point sometimes, if you're going around here, and we're catching up. Let's go around a bit more. So let's go around, all the way around here, a bit more, do 1.5, and then we get back here again to the same bit. What we actually start seeing as we're getting up to Mars here, Mars is like this. So it's, oh, Mars is slowing down. But then I see a change, and it looks like this. It looks in the sky that Mars, we've got all the stars in the background, there's all the stars, they stay still. Mars comes in and does that. It moves this way, then it slows down, moves backwards, and goes back there. Because sometimes, let's see if we can get a different colour pen. It's like the 2 different paths. I'm going to do little dots, dot, 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 and some longer dots here for the Earth pattern. Earth is going much faster, I can see here, but it's got different points when it catches up. So 1, 2, 3, 4. And it depends on different stars I see behind. Here, I see it slowing down. But sometimes I can see Mars go back. I'm like, whoa, where are you going? If the Earth was at the middle, I would always see Mars go round and round and round. But I don't see that. Most of the time, it goes round. Fine. But sometimes, as Earth is getting close to it, Mars is changing speed compared to Earth. So Mars ends up, so it's strange. This should not happen. So that's how we know that we have the Earth in the not in the middle. Oh, that's how we know the Earth is not in the middle of the solar system. The Sun is in the middle. Everything else goes around that. Thank you very much.